Hi everyone! You probably already noticed that JavaScript is rather important as a web development language nowadays. That's why I decided to make the first module of my JavaScript bootcamp as well as my ES6 bootcamp available for free on this channel. That should give you the very basics or changes with ES6 you will need to, work with JavaScript. If you then want to dive into JavaScript deeper, feel free to take the full courses. I'd be very happy to welcome you there. But if you don't want to, that's fine. These free videos or this free video here should get you started and give you the very basics you need. What is ES5 and ES6? Well, if you're watching this course, you probably do know that, but just to give you a quick refresher. ES stands for ECMAScript, which kind of is the language in the end. Though of course we say JavaScript all the time, but theoretically ECMAScript is the language and JavaScript is more like a dialect which follows ECMAScript. But of course JavaScript is the most popular language using ECMAScript, and therefore you can kind of think of ES6 just being the next JavaScript version. But what are ES5 and ES6 to begin with? Well, ES5 is the version which currently runs in the browser, and ES6 is the next gen version, so with new features and so on. ES5, as I just mentioned, is supported by all browsers, but for ES6 you will need some polyfills or transpilers, which basically takes your ES6 code and rewrites it in a ES5 styled way, which kind of sounds strange, but it allows you to use ES6 features today and kind of does what you would have to do in the past to do the same in ES5. It does that for you, and so you're able to run ES6 code today, even though browsers don't fully support it yet. This course, of course, will focus on ES6. Throughout the course, this is what you will see most of the time, jsbin.com. It's a great website which allows you to, if you just check JavaScript in console up here, write JavaScript code on the left, and then if you log something to the console and hit run, you'll see it show up on the right. And I will use this format throughout the course since it allows me to really focus on individual topics and show how they work and quickly play around with them without having to mess around with HTML and changing something in on the HTML page, which you then would not see, and so on. So rarely I will come back to using HTML and actually showing something on the page, but most of the time I will just stick to JavaScript and the console. Now, and if you rightfully say, well, my application won't just log things to the console, well, it isn't really that hard of a step from logging it to the console to altering something in your HTML document. And indeed, in the final project of this course, we will of course do that. So this is the format I will use most of the time, and it should allow me to really give you a lot of tiny examples which should allow you to quickly understand all the new things being added with ES6. Hey, in the last lecture you saw the format I'll use throughout this course. So I will use JSBin, a web page, to show all the ES6 features and how it works, and I explained why I do it like this in the last video. However, if you build your own applications and you want to use ES6, you'll probably do that on your local machine, right? So you need to know how to set this up, how to set up a development environment which allows you to use ES6 on your local machine. Because remember, browsers don't support all the ES6 features right now. So therefore you need a way to run it on your machine nonetheless and code or work with ES6 code. In order to do this, you basically need three things. The first thing is a package or a tool which compiles your ES6 code to ES5. Now you might say, how does that work? Well, basically it finds some hacks, some more difficult ways to achieve certain ES6 behaviors with ES5 code. And keep in mind that is only a temporary solution until ES6 is natively supported by all browsers. So that's the first thing, a compiler. The second thing is a module loader. You will see this later on in the module or section in this course, that if you're working with modules, so you have a lot of JavaScript files you want to load dynamically, you need a package to do that, because this behavior also isn't supported natively by browsers yet. So you need a module loader too. And lastly, you need a little server serving your application, because even though it is static, since you're working with modules, those modules need to be served dynamically, and therefore a little lightweight server is needed for, well, development too. Now, you can install all these things with multiple options. For example, as a compiler, you might use Babel. As a module loader, you might either use Webpack kind of, or System.js as a pure module loader. And for servers, there are tons of options. Attached to this video, you will find a document leading to some example setups or boilerplates on GitHub, which you can simply clone to get started, and where you can dive into to learn more about how they are set up and which compiler and so on they use. For example, here I have this vanilla ES6 JSPM package open, which also uses JSPM, JavaScript Package Manager, to load all those packages needed to work with ES6, and you can simply follow the instructions on this page to set up a local ES6 development environment quickly. Of course, you will find a link to that repository in the video or in the document attached to this video. Hi. An important thing to realize is you're learning ES6, but it's not natively supported by all browsers, or all the features are not natively supported by all browsers yet. So that means you can't use ES6 in browsers right now. There are some features you might be able to use, but for most of them you will need some kind of compiler compiling your ES6 code to ES5. And you will see this in a later lecture where I talk about a local setup on your machine to use ES6 today. Nonetheless, if you want to find out which browser supports which feature and so on, you should visit this GitHub page here, to which you will find a link in the attached document, in a document attached to this video. And there you will see all the important new features on the left here. And then on the right, you can see which browser version, so like Internet Explorer, Firefox, Chrome, and so on, and which compiler, possible compilers compiling your code to ES5, support which feature. So for example, if you're interested in for-off loops, you would see that the most recent versions of Chrome support this, for example. And that's an important chart you should have a look at regularly if you're working with ES6 applications, since it will tell you if you need a compiler, or if you, for example, only target the latest versions of Chrome, if you don't need a compiler because all the features you need are already supported, which might be possible too. So definitely check out this compatibility chart here to find out which features you can use natively today, and for which features you will need a compiler in order to use them. Hi, welcome to the first content module in this course on ES6. In this module, I want to have a look at the most important syntax changes and additions ES6 brought, and there are quite a lot of them, so let's dive right into it. So I'm inside JSBin here to type my TypeScript code here on the left, and then see the output in the console right here on the right. And the thing I want to start with is let and const. So let and const are new keywords added by ES6, and they allow us to change the way we work with variables, or, like the name const implies, use constants. So before I come to the question why we need that, let me first show you how it works. Imagine we have a variable name, and in the past you would have said name equals max, for example. And this will still work. If I print this name to the console, we'll of course see max. So var still exists with ES6, and of course that will always be the case since we need it for backward compatibility. However, ES6 also offers a different way to create a variable. We can use let. Now, with let, what do you think will happen if I hit run? We still see max. So it seems like it's doing the exact same thing, just a different syntax, right? So why would we use let instead of var? Well, if you maybe remember my JavaScript bootcamp course or are in general familiar with JavaScript, you'll probably know that we have the global scope and the function scope or the local scope. But JavaScript doesn't really have any block scoping, and block scoping of course refers to the fact that a variable is contained between curly braces, like in an if statement, for example. So in the past, if we had something like this, if true, and then between the curly braces, so in the body of this if statement, we would have a variable named name, which would be max, and if we hit run, this would work. Now with let, this variable is now contained inside this block. So what do you think will happen if I hit run now? I'm referring to the name of my window object, and it becomes much clearer if I use another name like age, for example. So if I now print out age, we'll even get an error that age is not defined. So let allows us to use block scoping, which means contain the variable in the body, like here in the truth in the if statement, where it is defined. So if I define it outside of there too, let's say I also have age of 30, what do you think will now happen if I ever hit run? Well, now I see 30 because, again, the part inside the if statement inside this block, that's why it's called block scoping, isn't touched. It isn't accessible outside of this statement. Therefore, if I log the age inside of this if statement, I'll of course see 27 and 30. So I'll first print 27 inside the if statement and then 30 outside of it. And that is why let is really useful and powerful. It allows us to finally use block scoping in JavaScript 2, which of course is an important addition, clearing many of the confusions that might have arisen if you used variables in, let's say, for loops, and you were able to access them from outside, or even the value might have changed inside of that due to some external value being set or anything like that. With let, you can make sure that the variable you use inside of a block stays inside of that block and isn't touched from outside and isn't accessible outside of it. So that is why let is really powerful. Now, why wasn't var just changed to work like this? Well, of course, for backward compatibility reasons. If you would change var to behave like this, you would pretty sure render a lot of code useless because var was used in a different way. Therefore, it's important to have this new keyword let. So that was a lot of talking about let, but it's really core to understand how let differs from var, that we are able to block scope with it, and that it otherwise behaves like var. It's a variable. We may change it. We may reassign age here to 29, and if I hit now run, we see 29. So we can use it like a variable. The important difference is the block scope. Now with const, it's a different thing. I'll get rid of my let code here, and I'll create a constant age 27. What do you think will happen if I now hit run? It's still 27. So that's not too surprising. But what happens if I now set age to be 29? What do you think we'll see in the console if I now hit run? Well, we'll get an error that we're trying to assign to a constant variable. So this really is no variable in this case, it's a constant. It may not be changed. Therefore, it's common to write it all uppercase to clearly show that this is a constant. And if we ever try to change it, we will get an error because that is not possible. A constant is defined once and then it should keep its value. Now, what do you think will happen if I create an array, ages here for example, with 27, 29, and 31? And of course I can print ages here. If I hit run, well, we see the array. Now, what do you think happens if I push a new value onto that array and then print it again, like this? What do you think we'll see in the console? Will we get an error? Well, we see the original array, and then we print a new array with 25 added to it. Now that's certainly strange. Didn't I say that a constant may not be changed later on? But it seems like we did change it, right? Not really. Remember that arrays as well as objects are reference types. This means, what does this constant actually hold? It doesn't hold those values. It does hold a pointer to those values, a pointer to this array. The array is placed somewhere in memory, and the variable or constant here only holds a pointer to that space in memory. Therefore, we don't change the constant, we're not changing the pointer, we're not pointing to a new object. We're only changing the values to which the pointer points. But that is totally valid. We're not hurting our constant here because, again, the constant value, the pointer, isn't changed, only the value in the background. That's why we are able to manipulate this array, and for the same reason, we would also be able to change an object. Like, let's say we have our constant object, which might look like this. And here we have our age set to 27. Now, of course, I print object here, and thereafter, I'll also print it down here. Thereafter, I'll go to my object and change the age to be 30. If I now hit run, we also see that the object was changed for the very same reason as the array. It's a reference type. The pointer isn't changed, only the value. I'm really stressing this because this is important to understand how constants work here and why you are able to change the constant, or to be precise, to change the value of that constant if you're using with reference types, because you're not really changing the value, only the value to which the pointer is pointing. We also have important implications regarding hoisting. Remember, hoisting referred to the fact that I could set something like this. I could set my age to 27, and then I could print my age, and I could define it thereafter like this, or declare it like this. If I hit run, this would work. Now, let's see if it also works if I use let. What do you think will happen if I hit run? Well, since I was asking like this, you probably expected this result. We're getting an error. So the hoisting of variables with let or const doesn't work the way it works with var. We have to declare our variable before actually initializing it. And this certainly is a good behavior because there really wasn't any big advantage of the old approach of pulling everything up at the top and therefore probably leading to bad code or you forgetting something. It's better to get a clear error if you forget the declaration before the initialization. So if I run this code, well, we see 27, so this works. And again, I think this is a change that really makes sense. What of course still will work is if we have a function do something, and here we, for example, have our age variable, set it to 27, and then I have let age like this. Now I call do something and I log age. Now what do you think will happen if I hit run? I get 27, so here it does work because actually it is declared before it is used, as I'm calling the function after declaring the variable and the function is the place where I use the variable. So therefore this is a valid approach and this will work. But if you really think about it, as I just mentioned, it works the same way as before. It is declared before it's being used, and that is the core thing to keep in mind. You have to declare things before actually using them. So we had a look at let and const, but another important field where a big change happened are functions. You probably know the way to write functions like this. I have my function with parentheses, and then I have my function body where I may do something, for example, log hello to the console. And if I now run this function like this, you'll of course see hello. So that isn't too new, but ES6 introduces a new syntax we can use to write our functions. I can rewrite this function here in the following way. I can assign it to a variable, fn, set this equal to, and then I keep the parentheses, but then I use this fat arrow, so this equal sign followed by the greater than sign. And if I now hit run, what do you think will happen? It still works, so this is just a different way to write this function, and I'll explain what happens here. The pair of parentheses here stands for the arguments we want to pass to this function. So in this function we're not passing any arguments, but an important thing to know is we always have to provide the empty pair of parentheses if we're not passing any arguments. Then, separated by this fat arrow, as it is called, you have the function body, and then inside of this body you execute your code. Now, since we're only having one line of code, there's even a shorter way to write this. I can remove the curly braces and simply write the function like this. If I now hit run, you'll still see it works. So again, if I only have one line of code, I may leave out all the rest and write my function like this. Now, while this might look a bit strange, it's simply a shorter way to write our functions, but it also has another feature to which I will come back later. First, I want to talk a little bit more about the syntax and how it works. Here we're printing something with the console, but imagine actually we would expect to get something back from this function which we could print to the console. Now the cool thing is, if all your function does is have one line of code and return something with that line of code, you can also simply write this. So no return keyword or anything like that, just what you want to return. If I now hit run, what do you think we'll see? Well, we see hello. So this function here is technically the same as this function here. Just much shorter, of course. So that's one thing, but what if I do have more code than just one line? Well, then I reintroduce my curly braces here. And then I can do whatever I want to do. For example, I might have my variable a and my variable b, and I want to return a plus b. If I now hit run, what do you think we'll see? We see 5, so we're using this function body like we would use it in a normal function or like in a function we know it from the ES5 syntax. So this works fine. But we also have this shorter way of writing it if we only have the return statement, the way you saw before. Now let's also talk about the arguments. I'm not passing any arguments, and I said that you need to provide this empty pair of parentheses in this case. So how does this change if I actually do pass arguments? Let's say I want to pass a and b to it, so like 3 and 8 for example, and I'm expecting a and b here. And then this is the syntax how I write this. I'm simply passing the arguments inside of the parentheses, like I do have it in the traditional function statement you probably know. And then I can call this function. So if I now hit run, we see 11. Now note, of course, that I, again, can get rid of everything but the a plus b term here, since I'm only having one line and I'm returning this. So if I hit run with that, I also see 11. Now, the cool thing is if I only have one argument, so let's say I don't have b, but this is always 5, so I'm only passing a. What do you think will happen if I call this function like this? Well, I get 8. And what do you think will happen if I still pass another argument? Well, it's ignored. I still get 8. But here's another cool feature. If I only have one argument, then I may leave out the parentheses. And that's important to know. That is the only condition or the only case where I don't need parentheses if I have one argument. If I have no arguments, I need anti-parentheses. If I have 2 or more arguments, I need them too, but if I only pass one argument, I might write this function like this. Very, very short, of course. So if I now hit run, we see 8. And this is the shortest possible way I could think of writing this function, except for maybe trimming out the white space here. So these are arrow functions in its basics, or with the core syntax that is to it. And one advantage you see here right away is that you save characters, that it allows you to write functions in a more concise and shorter way. Of course, I can also use functions like this in, let's say, a callback. So if I have my set timeout function here, I may pass this function like this, and then as the second argument to this set timeout function, I pass the interval, 1000 milliseconds, so to do something after 1 second. Now, of course, here returning something doesn't really suffice, so I will instead simply log hello, and I'll also not get any arguments here, so I'll just pass parentheses like this. And the autocomplete here is really helpful, thank you. So if I now hit run, what do you think will happen? I get hello after 1 second. So this is a place where I could use arrow functions as well. Generally, I can use arrow functions wherever I used normal functions before, as in the end they are just functions, just a different syntax. However, there is one big addition to them that I haven't talked about yet. It's concerning the this keyword in JavaScript. As you might be aware, the this keyword oftentimes is the root of a lot of problems, or a lot of misunderstandings at least, and it can lead to code behavior you were not expecting due to the fact how this is assigned to different parts or different objects. And if you want to learn more about that, definitely Google for some articles on it, or check out my JavaScript Bootcamp course where I will also explain how this works. Now here I'm assuming you are aware of how this works, and I want to show you how it differs with the new syntax, the fat arrow functions, and the old functions. I'll create a new function, the traditional style, and in this function all I want to do is I want to log this. Now I'm going to comment out the timeout for now because I first want to show something else. I will also give this function a name. Let's name it fn. If I call fn here, what would you expect to see if I hit run? Well, we get the window object. That's what we see here. The object or the window holding our application, the global scope. This is to what this will refer to generally. Now I'll also rewrite this with the arrow function like this, and here I will simply also log this. Now if I call this function here and I'll comment out the first function call, what do you think I'll get if I hit run? I get the window object as well. This doesn't change. It's still referring to the global context because this is the context in which this variable or this function here is set up, right? It's in the global scope. So it makes sense that this refers to the global scope, to the window object. So far so good. Now I'll get rid of all of that and also of my function calls here. And I'll pull that up to the top. Next, I'll go to HTML because I want to add a button here in my HTML body, and I will just click name it test. I also want to select my body here, so I will, or my button here, excuse me, so I will use a query selector here to quickly grab hold of it. And at the bottom of my code, what I want to do is I want to assign an event listener to this button, and you'll soon see why I'm doing all of this. I want to listen to the click event, and I want to execute the function, so the normal, the old style function here, if, well, this happens. And you see we still print this here. So now if I go to the output and I run my JavaScript code and I click this test button, what do you expect to see? Remember before we saw the window object, and this is what this should refer to. So if I click test here, what will we see? We get an object, but this is not the window object, as you'll see if you scroll to the top. It's our HTML button element. So this actually refers to what called this function. That's what I explained in the JavaScript Bootcamp course. So therefore this no longer refers to the window, but now it refers to the button, as the button is the one calling this function in the end. Now, this might be the behavior you want, but in most languages it is not the behavior you expect. You wouldn't expect for this to change its context here and to refer to different things depending on what calls this function. Generally, you would expect that this always refers to what it refers when you define this function, so the global scope in this case here. So if I exchange my event listener to now use function 2, the arrow function here, what do you think will now happen if I run with JS and then click test? Now I actually get the window object, as you can see if you scroll up all to the top here. So the fat arrow function actually keeps its context, and that is super important to understand because that really is the main difference. Saving some characters, shorter syntax, that's all nice, but the key difference to understand is that this is treated or handled differently. With the fat arrow functions, you won't need bind or apply or call, all those workarounds you used with ES5 to get this to the right context, but it will just keep the context in which this function is defined. So if this refers to the window object here, it will refer to that window object no matter how or where you call this function here, this fn2 function. That's super important to take away. And the other function, the old style, which you may still use, it's not bad by any means, it's just important to understand here this will behave like you know it to behave in JavaScript. It will change to what it refers. And that is a super important key difference. So that has been the fat arrow function. I was really stressing this because it is a key addition in ES6. Now functions also got some additional new tricks, and what I'm showing you now applies to both the traditional functions with the function keyword as well as fat arrow functions. But since it's a bit nicer to read, I'll stick to the traditional functions with the function keyword here. If I have my function is equal to here, for example, and this function expects a number and a number to compare to, and then let's say it returns if number is equal to compare, then I of course can call this function and log the result like this, is equal to, and then maybe 10 and 10. If I now hit run, unsurprisingly I get true. However, with ES6 we can assign default values to arguments. For example, I could give compare a default value of 0. So if I now call this function with only one argument, 10, what do you think I'll get? Well, I get false because now I'm trying to compare 10, which I'm passing as number, to compare, which I don't pass but which is set to 0 by default. If I change default to 10 and I hit run again, I of course get true again. So these are default values. Now I can also assign a default value to number, and now I can call this function without any arguments at all. And I still get true. Now what happens if I do this? I set number to be a default of 10, but compare doesn't get a default value. And now I call this function with 10. What do you think will happen if I hit run? I get false. And the reason for this is I'm still setting number to 10 because I'm only passing one argument, and this will set the first argument. And I can prove this by logging number and then also logging compare. And I will set the argument here to 11 to be different, or to be not equal to this default value. So if I now hit run, what do you think we'll get? Well, we get 11. That's what I pass for number. Then we get undefined because we're not setting compare. I'm not passing it. I'm not setting a default value. And then of course I get false because 11 is not equal to compare or to undefined. So that's important to understand. JavaScript will not pick the values which don't have a default value or the arguments which don't have a default value to assign the values you're passing. It's still keeping the ordering, and if you pass one argument to a function with two arguments, well then only the first argument will get set. That doesn't change. It does allow you to skip the other arguments if you only want to set the first one. That does work, but not the other way around. So if I now hit run, we of course get 11, that's what we pass for number, and then 10, which is the default for compare here. We may not only do this, we may also do some calculations here, like 10 divided by 2, for example. And if I hit run now, we see that it is 5. How much sense that ever may make, but it's possible. But an interesting thing is you can also use the other arguments, like this, number. So now I'm setting compare equal to number, and what do you therefore expect to happen if I hit run? I get 11, 11, and of course true, because I'm always setting compare equal to number if no distinct value is provided. If I do provide a separate value for compare, and now I hit run, well, we see we're still overwriting this. It's just a default value, and we are able to assign a different or another argument as our default value. We may also assign some kind of variable we have outside of this. Let's say we have a, which is 100, and I do this. What do you think will happen if I now hit run? Well, now compare is 100, so we may use our variables from outside of this function as well. Now, with that being said, what do you think will happen if I do this? I set compare to 10, and I set number to be equal to compare. And then I'm calling this function without any arguments. What do you think we'll see? Will we see true because all is 10? We get an error that compare is not defined. And the reason for this is you can think of this function argument list here as, well, just some lines of code, only wrapped in one line of code. And what we're trying to do here is we're trying to use a variable compare before it's being set here. So this does not work. We can't set something equal to something which doesn't exist yet, as compare will only be created in the second step, in the second argument. So this does not work, but the other way around does, because if we now set compare equal to number, number has already been defined before, and therefore if we run this, we get true, and both values are 10, of course. So that are default values at work, and of course the great benefit of default values are that you can write more dynamic functions which might work in, well, different circumstances, which don't necessarily need, for example, 3 parameters to be passed to them. They might work with 1 and the other 2s are set by default and so on. And you can really play around with that and try out where it works for you, what you can pass, and how all of that fits together. But together with arrow functions, the default values are really a big addition to JavaScript functions and certainly helpful in your day-to-day coding. So we had a look at let and const, and we also had a look at functions. We also had some nice additions or changes to object literals. What is an object literal? Well, I'll give you a brief refresher. We have an object, and this is an object literal. If we create it like this with curly braces, we might have a name inside of it, which is set up like this, and we might have an age. And of course, we can print our object like that. And if I hit run, we see the object. Great, so that is what we know and how we know it. However, JavaScript or ES6 added some additions. For example, we might have a variable Anna and also the variable age, which is set to, let's say, 25. And now what do you think will happen if I remove that? So I'm not assigning any values in here. What do you think will happen if I hit run? Well, actually, the object will take the values from the surrounding variables. So if we're not specifying values in here to initialize this object with, it will automatically look if it has variables declared before the declaration of this object here, which match the property names here. So name and name, and age and age. And it will automatically take those values. So that is a good way to quickly initialize an object with the values of some variables you already have in your code. Of course, you can still override this, and I could still set name to max. If I now hit run, we see that age is still 25, but the name was overwritten, so this still works. It's just a shortcut you may use. You may not only define properties this way, you can also define methods or functions. So for example, you could specify greet here, and priorly you would do it like this, function and then your function code. Now you may simply add parentheses here and then the function body right away. And then here you can print out this .name, for example, and then this .age. Now, if I call object.greet, what do you think we'll see? We got max 25. And so this name refers to the name in here, and this age refers to our age, which is set with the variable outside of this code. There have also been some other additions. For example, you already knew that you could create property names as a string as well. You can also do this for methods. So I can wrap greet in quotation marks here. And of course the parentheses have to stay outside of them, as they are not part of the name, but instead they indicate that this is a method. And now if I want to call this function though, I have to use squared brackets to access this property name here, greet, since it now is a string. So if I now hit run, this still works. This of course also allows you to use names you would not be able to use without quotation marks, like greet me with a white space in between. If I now hit run, you see this works, and of course this would not work if I were not to have my quotation marks here, since this is not a valid property name as well. I may not have a white space in there. As you can see, we get an error. Another cool addition are dynamic fields. So I'm going to switch this back to be a string, let's say here, like this, get rid of the dot so that this runs again. And now dynamic fields are an interesting thing too. Let's say I have a variable here and I name this age field, and this should be a string age. Now I can go into my object, and with squared brackets, that's important, that's the syntax here, I can refer to age field. And now what this does is, it does not create a property named squared brackets age field, but instead it will look for this age field variable and use this string here, as a property name. And I can show this by printing the object out to the console. Now what do you think we'll see if I hit run? We get an error, and the reason for this is now it's not able to automatically take this value. And of course it isn't, because string age is not the same as this variable name age. So in order to get rid of this error, I will have to manually assign a value here again. So now if I hit run, you see we now print out this object and then max 28 here. So we are able to dynamically add a property name age, as you can see here, and don't be confused that you're not seeing the quotation marks here. You are still accessing those values via quotation marks like you see here with the function call. But as I said, it's not able to automatically infer this value here anymore, since, well, age in quotation marks is not the same as this. So this is how you can dynamically assign certain property values, and of course you can also access those values. So let's see what happens if I print the age of my object here, and I'll get rid of the greeting for now. So if I now hit run, this still works. And you also saw that it worked because here in my function call, I'm still accessing this age. So I can still use dot notation for this field name since it doesn't have any invalid characters in it. It's not like the greet_me function here. So I can still access it with dot age. That does work, and that's important to understand. Now, of course, you can also access it like this. Age field, the variable which holds the property name. If I now hit run, you also see 28. And that is one of the important things here. You can create properties dynamically with the names stored in variables, and then you can reuse those variables to access those properties. Probably a use case you will have in your apps if you work with that kind of property creation, that you want to access your property names in the variables later on too. And you can do this, you can pass it to this squared brackets notation to access your fields in this object. So that were some additions to the way you work with object literals. The fact that you have these shortcuts to initialize your fields or to set up functions, that you can put your field names here into quotation marks, your function field names, that you also have those dynamic fields like the age field here. So a lot of little additions which might come in handy when you're actually writing your applications. Now in this lecture I want to introduce the REST operator. Now what is the REST operator? I'll best show it by presenting some code. So let's say we have an array of numbers 1, 2, 3, 4, 5, like this. And then we will create a function which I will call SumUp. And this function should somehow get this array, or should get a list of numbers. And then I want to loop through them. So let I equals 0, I is smaller than, to add should be the array I get here, to add length I++, and then I will simply have a result variable which takes the value of the current iteration. Of course I'll initialize result here, which should be 0 at the beginning, and then I will return result. And if I now call this function here, SumUp, and I pass numbers, this numbers array, what do you think we'll see if I hit run? We see an error because it is extremely helpful to write this correctly, as well as to use a semicolon here. So now if I hit run, we see 15, which is 5 plus 4 is 9, plus 3 is 12, 14, 15. Okay, so that works, that's great. Now, sometimes there are cases where you don't have the numbers you want to add or you want to work with, the values you want to work with in an array. Instead, you have a list of values and you want to be able to pass this list of values. So let's say I have 100, 10, and 20, and this is no array, notice that. It's just a list of values. These are free arguments. However, I'm only expecting one argument, and my SumUp function also has no chance of knowing how many arguments it will get. Might be 1, might be 100, it doesn't know. So I can't write it with, let's say, arg1 and arg2 and then add them up. That is not possible because I would need to know how many arguments I get. That is where the REST parameter comes in. It allows me to still get to add this array, but since I'm not passing an array, I add 3 dots in front of it. The 3 dots here are the REST parameter, and the 3 dots will actually convert this list of numbers into an array of numbers. So if I now hit run, you see 130. And to make this clearer, I'll even print the toAdd argument here. And if I now hit run, you see that this actually is an array, even though I did not pass one. You also saw that behavior in the past. In ES5 already you have, for example, the math object with the max function to get the maximum value. Now this function also expects to get a list of values and not an array. So internally this function was already using something like this to, well, be dynamic or to be flexible regarding the number of arguments it gets passed. And now you're able to write something like this on your own with the rest parameter, which simply takes a list of arguments, doesn't have to be numbers, could be strings, could be mixed values, and then just packs them together in an array. So therefore, if I, for example, do change one element here to be of type string, if I now hit run, well, you see we got it also packed together into an array, though of course the value now differs because it first added 110 and then it just added 20 in a string here. So therefore we got this string value instead of the correct result of the addition. But it still works. We are able to pass anything here and convert it into an array with the rest operator in this function argument here. That's important. We can use the rest operator in this function argument call. Now, kind of the opposite of the rest operator is the spread operator. Actually, it looks exactly the same, but you use it in different places. Where do you use it? Let me show you. I'll first create a variable numbers, which is again an array of numbers, but this time I want to get the maximum. Now, I was already mentioning that you already have the max function on the math object, but if you try to pass numbers here, what do you think you'll get if you hit run? Not a number, because this max method here actually expects to get a list of arguments, a list of numbers, and not an array. Now that's bad because we only have an array, and in the past you would have to manually split it up somehow and make sure that you make a list of arguments out of that. Now with the spread operator I add my 3 dots again, and remember the difference is before we had it in our own function in the argument list. Now we have it in a function call in the, well, list where we pass parameters to the function, so the exact opposite place. Now here with the 3 dots, if I now hit run, it works. And why does it work? Well, let's have a look what happens behind the scenes. If I print out numbers with the spread operator in front of them, and I hit run, we see that it actually kind of loops through this array and prints all those numbers. So it takes the array and splits it up into individual values. That is what the spread operator does, and therefore it's the opposite of the rest operator, which takes a list of values and creates an array of it. So rest and spread look exactly the same, they differ by the place where you use them. Rest is used if you write your own function in the list of arguments your function expects, and spread is used in your other code to basically split up an array into a list of values. ES6 also introduced a new loop to work with. Remember, in ES5 you already had the for loop, you had the while loop, the do while loop, and the for in loop to loop through keys in an object. With ES6 you also have the for off loop. And in order to demonstrate this, I'll create a new variable here, test results, which is an array. And here I'll just have some floating point numbers. And of course, it'll work with any values you might have here. So that's just an example. And then I can create this for loop like a traditional for loop. I'll have my test result, so no plural here, just a convention. This name is of course totally up to you, of test results. So the second part here is the value or the variable through which I want to loop through those values of this array. And the first one is to which individual element of this array will be assigned to in each iteration of this loop. So now I can, for example, simply log test result here, and I saw that I have a typo, so I'll quickly repair this. And if I now hit run, what do you think will happen? Well, now I get the values printed out. Of course, this could have been achieved before with a for loop, but this is a shorter syntax and it's perfect for looping through arrays, and that is what it's there for, to quickly grab the individual elements of an array and do something with them here in this block of the for loop. So that's the for off loop being added. Pretty straightforward, but also pretty useful. Another interesting addition to ES6 are template literals. Now, template literals are basically kind of strings with extra features, and I will show that to you. So I'll first create a traditional variable here, a name with the value max. And of course I could print it out, but I'm sparing you this because, well, it's pretty straightforward what you would see. Then I will create another variable, which I'll name description. And here I want to use a template literal. I do this by using the backtick. That's the character you've never heard before on your keyboard. It's this angled quotation mark here. So there's not the normal single quotation mark, but the bit leaning to the left quotation mark. You need two of them, and then you might write multi-line strings, for example, like this. If I now print this description here and I hit run, you see it as this literal. Now that is a big difference already, because with normal strings, of course, this would throw an error. If I try to do something like this, you see we get an syntax error. So that already is an addition. It allows us to write multi-line strings like that, but it also has more in its pocket than just that. For example, we might use the variables inside of our template literal. So I might write hello, I'm, and then notice also that I don't have to escape here since I use this backtick notation. And then I can use the following syntax to print out a variable which is defined outside of this template literal. For example, my name. I use a $sign for this, and then curly braces, and inside of those curly braces, the name of the variable I want to print. So name here. If I now hit run, what do you think we'll see? We see hello, I'm Max. So with this syntax, I'm able to insert a variable inside my string here like this, without having to exit out of my string plus value plus quotation mark string like before. Here you have one text and you can dynamically output values. That's where the name template literals comes from. It kind of also might resemble, if you're using that, some templating engines you might use when doing some server-side or some general web development, where you would also have special syntax to insert values in your HTML code if that is something you're aware of or you're using. So that is kind of comparable here. And with that, we have a very quick and good way to write more complex text and store it in a variable, use multi-line and so on, and also output our variables inside of it. Inside of this template expression, you might also add text again, so like multiple exclamation marks. So if I now hit run, you see them here. So even though that's inside of this template expression, inside of this curly brace block here, well, I added like we used to with a plus sign and then the string. So in the end, what we're doing here is between those curly braces, you have to enter something which can be resolved to a string. And then you might do whatever you want to do here, run some calculations and so on, as long as the result of whatever you're doing here inside of the curly braces returns a string. That's really important. By the way, if for some reason you have a template literal where you need to actually print this out instead of replacing it with this variable, and so you can simply escape it with a backslash. So now if I hit run, you see the whole template expression here, and I'm not actually replacing name with max. So that is how you can escape it if you need to. And that are template literals, a nice little addition to allow you to quickly write more complex texts and store them in variables, as well as access different variables surrounding those template literals. Now the last topic I want to touch in this module is destructuring. Destructuring allows you to do what the name implies, to destructure a complex object like an object or an array into simpler ones. And I'll show you how this works. I'll start with an array, numbers, and this should be 1, 2, 3, let's say. And then the structuring works like this. Let's say I want to have 1 and 2. Now, of course, I could set a equal to numbers index 0, and then I could do the same for b and access the item at the index 1, and then I could print out a and b. That would work. Destructuring gives you a shorter syntax. Use squared brackets to destructure an array. For objects, as you will see later, you use curly braces. Then the values you want to, well, or the variable names you want to fill with values. And then, well, the object you want to destructure, numbers. So that, of course, is a syntax you probably haven't seen before because it's new. And prior to ES6, you didn't use squared brackets on this side of the equal sign, right? You would use it on the right side to create an array, but on the left, that certainly is new. Now, let me show you what this actually does by printing A and then also printing B. And I have the idea you already can guess what will happen. But what do you think will happen if I hit run? You see 1 and 2. So this is a quick way to extract values from an array. Now, of course, also I could add C to get the third value as well. The question is, what happens with the original array? Is it destroyed, or is it changed by this restructuring, or are we just retrieving copies of those values instead of actually pulling them out? So what do you think we'll see if I now hit run? Well, as you can see, the original array still persists. It's not changed. We're just getting copies of the values we're pulling out with destructuring. Another interesting question, of course, is what if I actually pull out more values than this array has? And now I want to print D here. What do you think I'll get if I now hit run? Well, I get undefined, because remember, you can think of a JavaScript array as kind of an infinite array where all the values you didn't set are just undefined values. So you can pull out as many values as you want, you will get them, they are just undefined. A different way is also to use the rest parameter here. You may use it like this. B, and if I now print B, what do you think I'll get if I hit run? I get a new array. So with the rest parameter, I'm basically pulling out all the remaining values, which I didn't destructure before, like A, and put them into a new array, which of course also is possible. This is a quick way to retrieve a part of an array. Of course, you would also have splice and slice for such operations, but as you can see, this is a really quick way to get certain values if you, well, need to get them. Needless to say, destructuring, of course, also works with arrays that have strings or something like this. So if I now hit run, this still works the same. Now back to the AB example. And I also retrieve C and D like before. Now you already saw that if I run this, D will be undefined, of course. With destructuring, you can also assign default values like this, default. If I now hit run, you see default. If I also assign default to A here, and then I hit run, what do you think will happen? We see 1. So this is kind of a mixture of functions with default values and, well, destructuring here. So basically you are able to prepare for the case that a value you want to pull out is actually undefined. In this case, you would get whatever default value you set up here. And again, this could also be a number or any type. But if the value is available, like here with A, where we actually can pull out 1, then the default will not be used, and instead we get the actual value we pull out with destructuring. Destructuring can also be used for something else. You can use it to quickly swap variables. So let's say we have A, which is 5, and we have B, which is 10. And we just want to swap that so that A is 10 and B is 5. Well, before you would need a helper variable c to temporarily store one value, then set one variable to the other, and then set c to the other one, and so on. So it was possible, but it had some extra steps. Now it's as simple as this. Use destructuring with the variable names you already defined, so b and a, and you assign it like this, a and b. So we're kind of destructuring on both sides, or here we're creating an array to be precise, we're constructing an array, and then we're instantly destructuring it. So here we're creating an array where a is the first element and b is the second, and then we're deconstructing it to, well, basically swap the values. So therefore, if I now log b, and of course also log a, if I hit run, I get an error because I shouldn't use let here, thank you. So now if I hit run, you see b, which is the first one we print, is now actually 5, even though we set it to 10 before, and a is 10. So the values actually were swapped. And this is a real quick way to do this in case you have some code where you need to swap certain values. Destructuring really makes this easy. Another thing you can do with destructuring, to go back to the array of numbers here, you can also ignore certain values. So let's say I want to pull out some values, but not all of them. I want to pull out the first one and the third one. Well, then I just leave an empty space like that and set it equal to numbers. And then I log a and c. I can also use the log function like this. If I now hit run, what do you think we'll get? I get 1 and 3. So 2 is simply left out as I reserved an empty space here in the rest operator, or in the destructuring operator here. So I simply left out this space where I could assign b, but I don't have to. And therefore I'm able to just pull out specific places in the array I want to destructure. You can also do something like this. You don't even need to declare your array. You can immediately, for example, destructure it like this, a and b. If I now hit run, what do you think we'll get? 1 and 2. So now I'm not even creating this array, I'm not declaring it, I'm not sending it to its own variable. Instead, I'm immediately destructuring it to just get a and b out of it. Now, this is kind of a way to also quickly create a and b variables initialized with 1 and 2, if you think of it like this. So that is another way to use destructuring. So now we always considered arrays, and destructuring is also available for objects. Basically it works exactly the same, and all the tricks or things I showed you are also true for objects, but I still want to show it. So I'll create an object, and yes, like with the array, I don't have to create it and then destructure it. I could do it all in one step, like you saw it in the last lecture on arrays, but I'll still do it in 2 steps just to make it a bit clearer. So I'll have a name, Max, and an age, 27. And next I want to destructure this. So I want to get name and age out of this object. Now this would be as you use it with arrays, with the squared brackets. However, here we're destructuring an object, and therefore we have to change this. We have to use curly braces here now. So now I can destructure it like this. And this will pull out the name and age field from my object and store it in individual variables. So I can now print name and age like this. If I now hit run, what do you think I'll see? Well, of course I get max and 27. So this works exactly as I just described it. If I also have a greet function here like this, do you think I also can pull out this greet function? Let's say simply by doing that. And let's leave out the middle one just for styling reasons. If I now call greet like this, do you think this will work? What will happen if I hit run? This doesn't work because for styling reasons, we could do this in the array where we have a clear order. With an object, we can't just skip a certain value here. So I simply can leave it out though, because we're not having ordered properties here. We are identifying them by name anyways. So I can do this. If I now hit run, what do you think will happen? Now you see hello there. So this does work, but it's important to understand why this syntax didn't work. And the reason for this is, as I said, we're already referencing them by name, not by position. In the array, we were deconstructing them by position. Now we're deconstructing this object by name. Therefore, if we have name1 here, for example, this also, or greet1, if I now hit run, this also wouldn't work, because greet1 isn't found as a property in this object. Those names here have to match. That is really important to understand. Now I explained that names have to match, so name has to match name and greet has to match greet in order to successfully deconstruct this object. But sometimes you want to have a different name for this variable outside of this object than you are using inside of this object. That's why when deconstructing objects or destructuring objects, you can use aliases. So for example, I could give greet an alias of hello. And then I could rename this function here too. And if I now hit run, it still works, because now greet here refers to the property name inside of the object, but hello will be the name I use outside of this object, like here. And if I still try to use greet, will that still work? What do you think will happen if I hit run? This won't work anymore, because now hello is the only name we may use outside of this object, so we have to stick to it. So that was destructuring on both arrays as well as objects. A really powerful tool to quickly, destructure a certain object or array to get certain values. Keep in mind that A, you're not changing the original objects or arrays, and B, that basically you can do the same for arrays and objects, but there is this important difference that for object destructuring, you pull out elements by their property name. For array destructuring, you pull them out by position. That is really key to understand and to take away here. And with that, you're of course free to play around with that and see what else you can do with destructuring and use that syntax to be useful for you. Wish you a lot of fun with that, and I'll see you in the next module. So with that, we finished this first module on the syntax changes and additions, the core syntax changes and additions ES6 brings. We had a look at let and const, we had a look at the new function, the fat arrow functions, and default arguments. We had a look at the additions to the literal notation of objects, where we could use strings as names for our object methods, for example. We also had a look at rest and spread and at template literals, so multi-line strings with values, variable values being output right inside of them, if you want to put it like this. And we also had a look at destructuring. All of that are very important additions which make JavaScript more powerful and give you more flexibility. And I really hope that throughout this module I was able to show you how all of that works and how you use it, what the limitations are, and why it might be useful. With that, it's time to continue to the next module, which will actually itself be about modules. See you there. Bye.